All right, thank you, everybody. So if everyone can just settle into your seats, we're going to get started. Cool. So your next speaker is Jeremy Kirkham. He has over 8 years experience in web development and is currently lead software engineer at Equium. He's also the founder of ActivePD. So he's going to be talking to us today about GraphQL in Rails.
Cool. All right, thanks guys. Pizza must be done, I guess. I'm here today to talk about, GraphQL in Rails. The reason I want to talk about this is that at my workplace Equium, we started a Greenfields project about April last year, and it was the first time we'd built a product in Rails, and it was the first time we'd really sort of used GraphQL, which is a fairly newish technology. So we'll start off with what is GraphQL? So GraphQL was invented by Facebook as an alternative query language, to sort of as a alternate to use versus a RESTful API. So from the GraphQL.org website, GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. It provides a complete and understandable description of the data in your API and gives the client the power to ask for exactly what they need and nothing more, making it easier to evolve your API over time and enables powerful developer tools. So from that, there's three really sort of powerful statements. It allows API clients to query only what they need. It retrieves all the resources in a single request, so there's less bandwidth, which is particularly important when you're developing applications over mobile. And for the developers, it's self-documenting due to the GraphQL type system. So to start off with, the GraphQL type system is how you sort of define your application, and it's built up of scalars, enums, objects, a couple of abstract types, lists, and not nulls. So for those of you coming from a strongly typed language, you're probably familiar with the type system. For those of you that don't, in particular Ruby, I'll sort of delve into what the type system does. I've built a basic application to show you as a demo of how to use it. So just quickly, we'll go through scalars, things like strings, integers, floats, booleans, IDs, and custom scalars that you can create yourself. Enum is a collection of related values. So here's programming languages, could be Ruby, Python, JavaScript, whatever. An object is basically a type made up of other types. So you might have an author type, or maybe that's a user type that has an ID, which is a type of an ID, a first name, which is a string, a last name, which is a string, and it might have an array of posts, perhaps. There's a couple of abstract types. So there's unions and interfaces. So up on the screen, we've got an example of an interface. So in Rails terms, if you think of something that implements like single table inheritance, for example, a post, that might have a few different subclasses. That's a perfect example of an interface. And a union you can sort of think about as a collection of objects that may appear in the same place in the schema. So that author may have a property called possessions. So possessions might be golf clubs, it might be a house, it might be a car. They're not particularly related, but they're all something that author has. It has lists, which is basically arrays. So this is again a Ruby example, so you can see the types and then the square brackets indicating it's an array, and then inside of it is strings, so you've got an array of strings. Not nulls, so these are a modifier for other types. Basically, when applied to return type, it indicates that that value is always going to be there, and when applied to input types, it indicates that it's a required field, essentially. So from the type system, you compose your GraphQL schema, which basically describes your application using that type system, and it creates a self-documented API. So a schema is composed of queries and mutations. So queries allow any clients accessing your GraphQL API to retrieve data, and mutations allow those clients to create or update. So between queries and mutations, you can get that whole sort of CRUD workflow. So this is just sort of a small example of some queries. So these are top-level queries to your schema that the API can get traversed through. So the example application that I'm going to show you guys in a minute, it's got 2 top-level queries, authors and posts. Actually, I think there's a third one that I've put in, but I'll show you that later. So this, basically the 2 places that the client can enter that API. And then mutations. So in the example application, there's a couple of mutations. So we can create authors, update them and delete them. And then we can create 2 types of posts, a blog post and an announcement, which are going to show you the union in effect. So blog posts and announcements, both subclass a post. So I'm using the GraphQL Ruby gem, which is up on GitHub. So I assume everyone will be able to get this presentation at the end, and the links in it are there. So the example app is a pretty simple CRUD application. There's 2 models. So we've got authors and posts. So an author can have many posts. Post belongs to an author. That's pretty straightforward. And then posts was subclassed for 2 types. So there's an announcement and a blog post. So just to show you that sort of interface type. I've got this app up available on GitHub. So again, the link's in the presentation. So you guys can check it out later if you want. So the demo application is pretty straightforward. All I've done is bootstrapped a Rails application straight out of the box. The only other difference is I've added that GraphQL Ruby gem. So you can sort of see gem files exactly what comes with Rails, and then we've got the GraphQL gem down here. So the instructions for using the gem are pretty straightforward. Add it to your gem file, and then you can generate the installation stuff, which creates a few things. First off, it adds a couple of routes to your Rails application. So the GraphQL route, that's the route that all client API requests are going to be made to. They're all post requests, which is a little bit different if you've come from a RESTful API and you're used to using things like gets, posts, patches, that sort of stuff. All GraphQL requests are posts, even for things like querying data. And the other route that it adds in the development environment is GraphQL or GraphQL, which gives you a neat little page here, which allows you to run queries against your API in real time. So it's really, really easy to sort of debug and test out your application as you build it, because you can run queries as soon as you create those sort of mutations and queries. So again, looking at the application, it creates this folder GraphQL, top-level folder GraphQL, with a mutations folder that I've added, a types folder, and then the schema. So the schema file has the 2 top-level mutations and queries, and then there's a couple of things, you guys can see the mouse, a couple of things here around my interface type. So if we just quickly have a look at my models, I've got an author model, which has many posts, a first name and a last name, pretty straightforward. A post model, which belongs to author, it has a title, And then 2 types of posts. I've got a blog post, which has a body, and then a announcement, which has a subject. So just using 2 basic examples here, they could be anything. So if we look into the GraphQL folder, we've got types for all those models. So first we'll have a look at the author type. So this is a object type, so we can see this is how we define object types in GraphQL. It's got an ID, a first name, a last name, and posts, just like you would expect. It pretty much maps the model. So when you're defining the fields, one of the things is if you follow the convention of the names of the properties of your models, it just automatically knows how to resolve them. So first underscore name resolves straight through to first name. So ID is an ID, first name, last names are strings, and then we can see posts are an array of the post interface. So if we have a look at the post interface object type, again, it's pretty straightforward, maps to the model. It's got an ID, it has an author, which is a type author, and it has a title, so exactly like that post model before. Then we've got 2 other types, the blog post and the announcements. So these were the subclasses of the posts. Basically, they, again, mapping the attributes of those models. So the blog post has a field, body field, and it just says that it interfaces the post interface. So basically, that's the GraphQL speak for saying it's a subclass of post. And then announcement, pretty similar. It's got a subject field instead of a body field, and it interfaces the post again. So what that means is we can now start looking at running queries against the data. So I've seeded my database, and we can start running some queries against it. Can you guys hear me still? Yep. Cool. So cool, so you guys can see that. This is GraphQL. We're about to write a query. Because of the GraphQL type system, it gives me type hinting, so I don't need to have read the application code. I can simply start typing, and it lets me know what things I can query and what sort of fields I can query. So if I hover over that, we can see authors is going to return an array of author. And the other cool thing that GraphQL has is this little docs tab, which you can open out, and it shows me all the things that I can query. So I can see I've got a top-level authors query, which returns an author. I can click on author, and I can see all the properties that that author has. So that just comes out of the box. I didn't need to document that anywhere. It makes it super easy for any clients writing code to query my API. They know exactly what they're getting. So I can see from here, cool, if I ask for the first name, I'm going to get a string. If I ask for full name, I'm going to get a string. If I ask for an ID, it's going to get the ID. So let's go ahead. So get the ID. Get the first name and last name, and then you can just run that query, and it returns the data on the right. So we can see I've got an author in my database. It's me, hello. And then the other thing it can return is posts. So I can see any posts that author might have. So posts, and then because that's a type, an array of posts, these are the fields that I can get from that post type. So I can get the ID and title of the post. Now that's cool, but we've got 2 subclasses of that post. We've got blog posts and announcements. What if I wanted to get the body of my blog posts and the subject of my announcements. How do I do that when it's a sort of generic post type? GraphQL has some pretty cool features. So I can do... So on blog post types, I can query any fields that it might define itself. And similarly, on announcements, I can get the subject. And I can even, where's my cursor? Get the type of the post. So run that again. I can see that that author has 2 posts. The first one is a blog post. The second one's an announcement. And I'm getting the body for the blog post and the subject for the announcement. So that's pretty cool. GraphQL, again, you know, I'm asking for what I need and only what I need. So the resolvers are only going to call the code that they need. So I've defined my schema as a Rails developer, and I've laid out all the connections between authors and posts and the different fields. But if you're a mobile app and all you're interested in is the first name of the author, why ask for the last name? That's less response size that's going to be returned. So, you know, you can sort of play around. And then the other thing you can do, which is cool, is that we know that a post belongs to an author. So inside of my posts, I can actually ask for the author again. So I've got a little bit of recursion going on, and I'll get the full name of the author. So we can see, you know, kind of makes sense, author Jeremy, all my posts, and then the author of those posts. So, and you can go on and on. GraphQL RubyGem lets you define how many times you can recursively ask for resources, so that's good. So that full name field we didn't define in our model anywhere. We could have, pretty straightforward, but for this example, I've added another field to the author, and I've just defined a resolver function for it. So like I said, out of the box, if your fields are labeled the same as the attributes on your models, the resolvers will just magically happen the Rails way. But you can define your own. So full name, rather than creating a full name method on my author model, I've added it to GraphQL, just an example. So it's just returning the first name and the last name as a string. Posts, it's getting all the posts for that author, which is great when you've only got a couple of posts, but once that author's been around and has written, you know, quite a lot, and they've been around for a couple of years, you're going to have a long list of posts. So returning all those posts isn't a great idea. You want to start looking at something like pagination to only return a subset of those posts. So GraphQL implements relay-style pagination. So relay is the Facebook's React. It's their front-end version of a GraphQL client. So instead of posts how we were implementing before, we'll define it as a connection. So that's basically all I need to do to get pagination. So if we go back to GraphQL and refresh and post, it now shows an error on all those fields because the post connection doesn't return those straight out of the box. We've got to ask for the edges. And then each node is a post. And then I can ask for things like title, ID, blah, blah, blah. So edges takes some parameters. Post does, so I can ask for the first 2 posts or 1 post, and then there's a couple of other information, so page info. Yeah. This is why I saved some of the queries before. Cool. So you can see we're only returning one post now. We've got the cursor of the post, which Relay can use to keep track of what page it's on, essentially. And then there's information like, is there another page? And there's things like, is there a page before it? Which the Relay library or even Apollo GraphQL will handle for you as well. So Apollo GraphQL is a sort of more wide-ranging JavaScript client. That's the client we're using at Equium in a Angular 5 front end. So that's queries, so that's querying your data, and then again, you can do things like pull the data, create posts and update posts, and create authors and update authors. Sorry, you got a question? Yep, sure. So like I said, I had a third top level query. So this field posts, which takes an argument of an ID, and it finds a post by that ID. So we can run that query. So you can see we're passing in an ID and then run the query and it returns the second post. So you can get pretty powerful queries. You can define as many inputs as you want. So it might be, you know, search on title, that sort of stuff, and then it'll just run it. So I'll just quickly do a demo of the mutations, and then I think that'll probably be question time after that. So mutations, they're run very similar, except down the bottom, you've got a place to put query variables. So that's essentially what the query is going to look like to create an author. This create author input, that looks a bit scary, what's that? But that's what this little field down here is for. So we're going to provide the variables that we want to put in for creating an author. So again, from the out-of-the-box documentation that provides me, I can see what that create author input looks like. So it requires a first name and a last name, so that's pretty straightforward. It's a terrible name. But that's created a new model in my database, Steve Buba. It's returning the ID and its full name. So if we have a look at the code, our mutations are stored in a mutation subfolder. So I've got a create author mutation. Description creates a new author. We define the input fields there, so first name and last name. That little bang at the start of the type string just indicates that it's a required parameter. And then the return field tells GraphQL what type it's returning. So we're going to return a full author object. And then the resolve lambda just tells you how to implement how it processes that input. So we just take the input's first name and last name, creates an author, and then returns that author. In the resolve lambda, there's a couple of things. We've got object, inputs, and context. So we're pulling the first name and last name from the inputs, but context is is quite useful as well. So the GraphQL controller that gets generated, you can provide some arbitrary things to your context. So you might be, maybe you're providing the current user. You might provide a logger. You might provide the pundit gem if you wanted to do any authorization on who's allowed to create authors, that sort of stuff. So you can pass them into the context there. So that's the create author mutation. We've got a couple of others. So you create blog post, very similar. So it takes an ID for the author of the blog post, the title and the body, and it returns a blog post. We've got create announcement, and then there's updates, which are very similar. So again, we just define the inputs that we want, and then what sort of code we want to run to do that update, and then a delete. So same thing. So that's pretty quick rundown of GraphQL. In terms of personally how I found it, it was really great. It sort of allowed two separate teams, the back-end team and the front-end team, to, back-end team could really sort of push out the API, and the client side didn't have to go, oh, what's the endpoint for this? What's the endpoint for this? Can it return that? It's all self-documenting. So like, oh, cool, this endpoint's here, it returns that. It was pretty awesome. So I think that's pretty much the end of my presentation. Yeah, thank you. Are there any questions? No. Yep.
Oh, is this working? Okay. Can anyone? Yeah, okay. I was looking at when you were defining like the types which then inherited, like you're doing your, your higher order blog post and then your higher post, and I noticed that you had an array in there. Does that mean you can do multiple inheritance?
Sorry, where was that?
That's a good question. in a file somewhere in there. Yeah, that's it. Yeah. I think it was the interfaces.
Okay, so on my blog post type, that's actually a very good question. I guess it could. I've never looked at it. I've never found the use case of something inheriting from more than one thing. So something for me to explore, I guess. Yep. Sorry?
Hi, I have two questions. Can you do a caching with this? And then the second one, if I were a mobile developer, how I would send the JSON, or how does it work?
Yeah, for sure you can cache it. And in terms of querying it from the client side, there's some really great libraries. So Equium, we're in the process of building a mobile app out, and iOS has its own GraphQL. I don't even know what the iOS libraries are called, CocoaPod or something like that. But we've also built clients out in JavaScript. So like I said before, the Apollo GraphQL library is really great. It's fully documented. You don't have to worry about writing the JSON yourself. It's very similar. You sort of define mutations and queries, and it just sort of matches up.
So in the, can I take one? In the create, say, author resolver,
Yep.
How do you handle the validation errors if, any of the...
Yeah, so at the moment, any errors are just going to fail and cause a massive, ugly JSON array. But the GraphQL gem allows you to return a GraphQL error type, which is a neater way of handling it. And then clients can, they can query that type just like they can query any other type. And then they can do what they want to do to handle those errors. So it's a neater way. I'll give you an example of, this is got no error handling. So this is what it currently looks like. Say I ask for If I ask for a post that doesn't exist in the database, you're going to get something like that, which is pretty ugly. But what you'd do is inside the resolver for finding that post, you'd basically catch that exception, and then you'd throw a GraphQL exception, and it comes out in a nice, neat, formatted JSON response, which the client can then decide what to do with. Yep.
Sorry, what do you mean by client? Do you mean somebody else who's working on the project, or like a user using the site?
In client, I don't mean, I mean like a client library. So they're whatever's consuming the API. Yeah. Yeah, not the people that pay us money. Cool. All right. Thanks very much, guys. Thanks for listening.